chapter 1 basically have a fundamental concept about technical drawing, right? Technical drawings. See, we talk about technical drawings. There are actually a number of names, right? We could hear, drafting, drawing, graphics, right? All those names, right? All those names, especially the drawing and the graphics seems used equally frequent. Right? I personally like the drawing name drawings. The graphics, meaning many things. Anyway, so it really, this technical drawing things really root back in long time. You imagine any type of, especially big construction, right? There must be some sort of planning and drawing down before the actual the project starts, right? Otherwise, how do the people coordinate all the activities, right? There must be some sort of plan. The detailness, the level of complexity, maybe different, but there should be definitely something, some sort of. You think about those just think about a big church, right? Those church could take over 100 years to build, right? You mean over 100 years, there's multiple generations. So there must be some sort of documentation there, so people could just generation by generation just continue working on that same project. So there must be some sort of technical drawing down there to really serve the purpose of technical drawing, right? So there's some sort of design on a paper or some form that the other persons can use. That's really what the technical drawings are. Some of you are taking the design 101 the same time. You will know have a lot more detailed study about the technical drawing and the foundations, right? But we just talk about the basics and we move on to how to use AutoCAD to create drawing, right? You see, this gentleman right here is called Mark. I don't know how to pronounce this March, but Gaspard March or Mark. Right? This gentleman, French gentleman, was really the pioneer in the developing technical drawing. He wrote a book called The Descriptive Geometry, right? That was a university course offered in, I think, the late 1700s. Descriptive geometry. We have that course. We have a design technology course exactly called descriptive geometry. Here this is the first thing about the projection. How do we draw objects? Yeah, this is the way we use lines to draw something similar to what we see. So this is the concept here is actually projection, right? Think about the projection. This is the object, actual object. By the way, how do we put the object onto paper? And that's through the projection. Just imagine there's some projection lines, just like a race, start from that and going onto this paper. That's projection. And this is the three views of the projection. So remember, when we do the projection, those projection lines, right? Projection lines, they're all parallel. Imagine, and we don't have those lines marked here. You think about every those points, right? Projection lines goes from the object onto the projection plane. This is called the projection plane, where that drawings are produced. So all those lines are parallel. So remember, that's a very unique property projection. But however, our eyes see things different. Not that way. We use the like a sort of called a perspective. But those projection lines from our eyes are not parallel, right? Not parallel. That's why we see the same object bigger if we are closer to the object. We know that, right? If the same project, even very huge, if they're so far away from us, it just appears to us so small. I mean, a good example would be like in the moon. And we know the moon's huge, right? Moon, I don't know exact size. I think at least 1/8 of the Earth, the moon. But it looks to us it's just like a hair, right? Right, and so that's the reason because it's so far away. That's what we call that type of projection is called the perspective. Right? So this is the parallel projection line. The way this is called what the real not isometric. This is called parallel. I think isometric. No, I'm sorry. I didn't come to that word. What is? Anybody knows this? Is a parallel way. This type of projection is called what? Orthograph. Yeah. Orthograph. Orthograph. That's the word I was trying to get. So you see that we have this perspective, which is just it depends on distance, right? And this orthograph is just like you see here. You imagine the position of this projection plate does not matter. So this plate can be closer to the object or far away. You think about even this is like a mile away from the object, does not matter. Those projection lines are parallel. Right? The parallel, two line parallel, that distance is always the same, no matter how far that goes, right? So that's a big difference, right? But the perspective way just look to us is more natural, right? More natural. We know that's one unique thing about the perspective way is even like the same thing. You see this like some object like this, right? It's just we know this is the same height, same height. You think about a wall, the wall. Normally the wall is the same height all the way. But if we stand on one end of the wall, just the starting end looks so much taller than the other, right? So that's perspective. That's why in those perspectives used a lot of time used for the like architectural render, right? Where you just draw the outside appearance of a building, so the people will look at it just real, more real, because our eyes look at the things that way. That's the only reason. It's really interesting, in the natural world, I don't know. I'm curious on what do other animals look at the world, right? What do other animals? It would be very interesting, right? Very. So let's move on, right? Let's just see. This is a what? CAD model, right? 3D model. So this days, we used to be say like a human being used manual, right? That was only available. Use pencil, paper, manually draw anything at their design. And then we had a computer like AutoCAD and other types of CAD software, and we used a computer to make drawings. So initially, that's why this CAD called CAD is computer-aided drafting. Basically, it's a drafting machine, right? So which is instead of using pencil, we just use computer to make the lines, circles. That gradually that the CAD becomes CAD, computer-aided design. Although there are two D's, same D letter, they mean different. Drafting really different from design, right? Design. And at this stage, we very much do the design 3-dimension, right? Whether that's architecture or mechanical. When I think about the mechanical parts, we just first start from 3D, right? 3D. And then we use that finish the 3D model to produce 2D drawings. Architectural same word. We have the Revit. You guys heard about that Revit software? What that Revit does is the same thing, 3 dimension. We just design walls, all the roofs, all the things, 3 dimensionally, and then we just make drawing. Right, so that's totally a new way. Of course, this is more exciting and easier to see a lot of details, right? But we still need to make 2D drawings, right? So the drawing is a 2 dimension, right? The actual models are all 3 dimension, but the drawings, is on paper, right? They're all 2D, 2 dimensional. AutoCAD versus 2D. AutoCAD could do 3D design, but it's not AutoCAD strength. We have other software. We have Enter SolidWorks, Creo. Those things designed for 3D design, right? So that's why AutoCAD is used for 2D drawing, creation, management, all of those. And AutoCAD has very strong functionality on 2D, entire 2D, manipulation, management, printing, design, right? So that's why still this days, AutoCAD is still the #1 CAD software. You see, this is the model, right? In the technical drawings, need to have all the dimensions. You just give them this thing. Well, it's almost people cannot use that because a lot of time we need to have human interaction, right, with the machine. Like you operate the machine, you need to know the size. Unless you have a really advanced the CNC machine where you can directly use the model. Yeah, it is becoming the reality, right? Becoming reality, but not everywhere yet. You see here, that's the drawing. Right? Use this model. You still need to create drawing, right? Now this is an example of architectural drawing, right? Architecture. You see this done on Revit. Remember, I just mentioned the Revit. Looks like those are floor plans, right? These are just an elevation. Those are some sort of a detail or sections, right? The same thing. See, when we talk about the architectural design, right? When we talk about design, any design, when you finish design, that design documentation need to have drawings, of course, right? And then in addition to the drawing, we a lot of times we provide some sort of maybe writing, right? To explain something, to include some other things. Right? Even the drawing is just not one drawing. But normally there's a number of drawings, right? For like a mechanical system, we need to have a drawing for every part. Right? A system has a different number of parts. Right? Every part, individual parts, we need to have a drawing for. And then we need to assemble the parts together so we get the system. And then we need to have a drawing for the system called the assembly drawing. Right? And at least we need to have those 2 types of drawings. See, the architectural design, think about a house. We design a house. What is the finished like documentation? You see, we need to have these drawings. First, we need to have the floor plan, right? Floor plan. There need to be one floor plan for every floor, right? You might be designing like a 20 floor levels building. Well, you need to have a floor plan for every floor. And then the side, this is called the elevation. Basically, this is the outside look of that building. Right? So you can imagine we might need to have for one drawing for every side. Well, normally build this 4 sides, but then we need to have 4 sides, 4 elevations, right? Then not done yet. We need to have many section drawings. See, this looks like maybe concrete foundation or something. This looks like a wall, right? This looks like a roof connecting with the wall. Right? So all this need because The ultimate purpose of design is to provide all needed information for somebody to make the part or to construct that house. So you can imagine, really depends on the project. There's really a lot of drawing needs to provide. Right? So this is the typical architectural drawing work needs. Right? What drawing work needs. That's why we have the different architectural course. Right? So we have architectural 1, architecture 2. We even have a class called residential design, and this is like a structural design detail. We have a class called the structural design detail that focus on this detail treatment. So you see this again, those are elevation. This is actually a better view, right? We know what is the elevation, right? South elevation, is the west elevation, east, north, every side, right? This is the floor plan, and this is the sort of like structural view, right? And it looks like this other type of architecture, right? And also in architectures, buildings also have what other systems like electrical, like plumbing, like air conditioning. So all those need to be designed too, and properly laid out. Right, laid out. That's pretty complicated, right? Complicated. And also why architectural firms design it, they always need the mechanical to take care of the mechanical stuff. Right. So yeah, really, you see, this is the civil, right? Civil, deals with the larger scale, like highway, airports, bridges, water dams, those big size, and also it does the like the site preparation. We say what we have a new site. They're just like a wild soil, right? So we need a lot of work needs to be done. There's some survey work, make sure what's the foundation, the composition, the condition, water level, whatever. Then in the design, you need to have an idea about the foundation, right? What type of foundation you will put it. Are you going to put a basement there, or just a slab there, or cross base volume? You might need depends on the nature of the design. There could be multi-level basement, right? You think about the bigger high buildings, and they may have 3-4 level basement. So it really depends on the project. And in this days, by the way, we talk about the civil. There are a lot of jobs comes from the civil field. I think it's because the government. You heard about the government, the president talk about renovations on the national highway, the interstate, the airport, right? So that's going to be a lot of work, a lot of designers, technicians. That's why we are clearly, we see we have a more companies looking for civil technology people. So you guys. If you are interested in architectural work, right? Here's my recommendations. Remember to take that Revit class. Revit, right? Revit is software. This piece, let me show you. This piece here. This is just like Autumn. That's the sister software of Autumn, called Revit. It's so powerful that that's the best design software for architecture these days. So if you are an expert of this master of Revit, there are plenty of jobs for you, right? Because the Revit is just so powerful. It could take care of every architecture, not only the structure, also the roof, the floor, but also the plumbing, electric, HVAC, right? It's good. So remember, in the future, take this class. The design, the class number is called 115. 115, design 115. Make sure to take that, right? And even for everybody, because this software is so nice, I really recommend everybody take this. You never know what opportunities come to you, right? So remember that class, we offer that all the time, right? Every semester. Let's see. So this is also the civil, right? Also civil work. So it depends on nature, right? Civil. And then what is this? Mechanical. Yeah, no, we're seeing mechanical. You know, mechanical difference between mechanical and architecture. First of all, you know, mechanical parts normally small, like what we call small. Of course, they're big, right? Like big vessels, big airplanes, those are big. But normally, especially consumer product, the part size is small. The first one. Second is the biggest difference between architectural and mechanical is the tolerance. You know, mechanical tend to be very precise. We talk about it in a magnitude of like thousands of inch, but very tiny. Well, architecture building does not venture that much, right? So there's some slight difference, but not that much. That's a big thing. And the mechanical system usually need to be assembled into one big device or system. Like architecture is just a building. So that those things. But the design as to design like a drafting point of view, let's say we just create lines, like different lines, distance, dimension, right? You see, this is a mechanical part. Right? This is just a one single part. Pretty complicated, right? There's some internal features, but this is one piece, right? You see all the dimensions, right? So that's the nature of the mechanical part. Sometimes we have to use the multiple more views, right? More views to describe parts. What's this? Those are the master cam. Yeah, those are the CNC stuff, right? You see the manufacturer pathways, right? This is Creo. Creo is another piece of 3D CAD. So the AutoCAD 2D, right? A 3D CAD software, those popular ones these days. At least there are, you know, the Inventor that's from Autodesk, right? And the Fusion 360 from Autodesk too. Then the SolidWorks from SolidWorks, another piece. And then this Creo, right? This Creo used to be called, I think, the Pro E, right? Pro Engineer. That's the old name, right? It changed to this Creo. This very powerful, right? Very powerful. Then you see this is assembly. Right? This is assembly. This is assembly, right? So we when we do the design system, we need to design both individual parts and the assembly. So the assembly, we need to assemble them together and create the assembly view, right? Assembly view. These days, because we have the 3D CAD software, you know, assembly can be virtually assembled in the computer, and then we can easily produce the assembly drawing. But before the 3D CAD was available, that's very, very challenging. You think about the design as something complicated. Let's think about a car engine, right? There's for brand new design, there's no model. Everything in your mind. You have to put everything in the right position in assembly. Right? It's very challenging. But now we don't have to do those things. So for mechanical design, we need to have part view. Individual part drawings, right? One tab. Then we need to have the assembly drawings. Right? To remember those. And there may be others. Right? These are mechanical drawings. It depends on the application, right? Application. So and also on mechanical drawings, we sometimes we have to specialize the design. For example, the sheet metal, right? Sheet metal design, a packaging design, right? And welding design. Those are the new sort of like a new field. So really exciting, right? this is you see this is like this is a case, right? It's like this is like some sort of a case. Okay? Uh, anyway, I'm not so many pictures. What's this? See, this is electronic. Like, electronic, and that's another. See, this is a circuit. This is called a schematic. Right? Schematic, which is the layout of the relationship between different components. This is just a theoretic function. Not necessarily means the actual the link between the components this one. No, it's just show the actual from the function side how those parts being. We see the circuit, we see all the wires, and this is the real thing. This is the board, right? Electronic printed circuit board. This needs to be shown accurate, accurate connection size. Right? So yeah, this you see, this is called what? This is the what? First of all, this here. This is a sketch. You know, sketch means a manual work. This is done by manually, paper, pencil, paper. And this is a very important in the design. One of course we have a number of practice to practice on this. So everybody design technology. And this way you might always try to practice your sketch skill. Exactly like this. So how to freehand manually sketch something. You know, here freehand sketch doesn't mean that you sketch free. We need to first follow all the standard. You see here, right? The different notation, different line type, right? Look at those letters, those numbers are done very well, right? In a manual drafting field, there's one section talking about the letter, right? How to write letters and the numbers. Nice, right? So there's a requirement that, right? You need to be done very neat, very nice. So you see all those letters, it's easy to read, right? No way you can misunderstood this, but that's a requirement. So a lot of time when you guys have a associate degree, graduate, and get a job from a company, you're going to do a lot of this. You think about it, you may just you may be sitting in a meeting with engineers and you talk about the design. You might be the guy just just quickly sketch down here, just like that, right? That's one thing. Secondly, a lot of times you could be given something like this, and then you will need to convert this one into this. You see, these two things so similar. Yeah, this is the CAD work. This is the part that is done by AutoCAD or software. So you need to convert this one into CAD. So when you do that, you need to understand all the details. What do they mean? What this means, right? So that's and in the design team, you guys are going to be the relay what the expert about the drawing, right? The team may have some people from with or other universities with bachelor's degree, master's degree, with PhDs, but they have their specialty. You guys' specialty is technical drawing. You have the power of a lot of times to determine what type of views, right, to put there. So that's your expertise. Right? That's why you should have this way in mind. Always practice. Even in this class, you use a lot. You could before you start make the drawing in auto, you could manually sketch, lay out the views. That's actually a very helpful process. Help you to figure out the details on all the views. Right? You think about it, we do a 3 views. You could quickly use a pencil on the paper to quickly sketch what's the front view look like, or what's the top view size. You see, that process is very nice. You with a pencil sketching, you can keep your seat. But when if you use the CAD, I think that's why so you should have this one practice on a sketch in your mind. Although we don't have it in this class. We don't have a assignment on freehand. No, you have those sketches in your one work. So you should really no, I see Jimmy asking, most companies get away from AutoCAD? No, they use a different software for different purposes. They use the SolidWorks for Revit for the 3D side of design. AutoCAD is still, I believe everywhere where they have the CAD, they always have AutoCAD. Right? AutoCAD is just in the 2D drawing menu, still number one. We'll say, I will show you later. Right? So this is a mechanical. Right? Again, mechanical. You see the model, right? 3 view is the front view. This is the actual part, how the part looks like. And this is the front view, top view side. When we talk about the mechanical detailed drawing or individual part drawing, this is one. A lot of time, you say we need to create a detailed drawings, and this is 3 views, right? Three views. And this is because a lot of time we use the 3D to do the 3D design first. So we have this already made that we use this 3D model to generate the 3D. Right? That's why we can easily just place a model at the top right corner. But if you say we use AutoCAD to do the design, so we don't have to create this one. You can directly just make the 3 views. That's it, right? Because the creation of this 3D this model very tough, right? So and the detailed drawings need to have all the detailed dimensions, right? We're going to talk a little bit about the dimensions too. And next, this is the called what? This is the measurement, right? Measurement, because that's very important. How to, because we have different units, right? Different systems. Think about in the mechanical, metric unit, English unit, right? English units, have this how many inch, how many one foot equal to how many inch, 12 inch, right? And all the different conversion, right? In metrics, different units too, like we have meters, much simpler, right? Metrics is so much simpler, so much easier to use, right? We'll talk about in the next chapter, I think. But these days still, especially in construction field, people just only in this country, people still only use English. They use the foot and the inch, right? That fraction, right? A lot of times they use that. But that's just the nature of business. You have to, when you do architectural design in this country, you have to use English, right? But the mechanical, I believe, mechanical field, they're quickly moving to metrics, millimeters, right? The metrics is so easy, and also so suitable. Think about it, a millimeter just small. So it's you look at this, right? Look at it. This is my camera, and this is the ruler. This is the inch. Inch is just it's this much. That's 1 inch. It's too long for precision measurement, right? But the millimeter is just small, very small. So it's suitable for precision, right? Precision measurement. But the strong thing about metrics, all by hand, is 1 meter equal to 1,000 millimeters. Right? And you just move the decimal place easily. Right? The big problem in the English unit is because that 1 foot equal to 12 inches. Right? So here is 12 inches, not a 10 inches. This 12 create all the trouble. That's why these days construction people still use the fractions, right? Fractions. That's very, 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 very. So anyway, we're not going to. And another concept is the scale, right? Scale. So when we actually put a drawing on a paper, we have to scale. Sometimes we have to scale up or scale down. Right? Especially thinking like a building. You design architectural building with hundreds of feet long. There's no way you could put a paper. You have to scale down a lot. Right? That's scale concept. Scale. But in AutoCAD, we always draw everything real size. Yeah, you could AutoCAD is unlimited space. We could draw 200 feet long. It doesn't matter. But once you need to print that drawing on paper, that problem, right? Because no matter how big the paper you use, the limit. Right? That's why in the old days, when we did the manual drawing, first is to calculate, decide the scale, how large to put the object on the drawing. Right? Yeah, let's move. You see this is called the right light design. This is the manual scale I mentioned moments ago. Lettering. Right? In your design 101, you remember you will have a topic called the lettering, right? Letter with that ing, letter. So basically, how to write letters and numbers well, right? See here, you see here, all those letters numbers are done professionally, very nice, right? Very nice. So this is first of all, this is a requirement. Technical drawing is very serious. Our numbers need to be accurate, right? We need to write them down very nicely, very legible. So any other person wouldn't have any problem in understanding. That's the first thing. Or the second thing, the profession, technical professionals tend to be very what I don't want to use the pick, right? It's not a good word, but a very high standard. They want to their work like this, right? Look great, very neat, very clean. So that's the entire profession. Everybody in the profession, they just hold this standard, right? So you need to be. That's why moments ago I recommended to practice the manual sketch, right? Not only manual sketch, also a lettering. At least you should be able to write down the letter. Not too bad, right? Not too bad. So that's why this is actually a manual drawing, I believe. So this is a manual drawing work, and it looks like the blue, and then it's reproduced. The drawing may need to be copied and reproduced in hundreds of copies. So this is using the blue, basically whatever the method they use, reproduce them for multiple copies. So I believe this is a manual work. You think about it, all those letters from there down, right? Very nice work.